Okay, so I've got all my screen keys on and I've made up a little sort of drill area to take you through topology and some of the keys to it. I'm going to start in here with the humble grid. As you can see, a good grid, we can tell something is good topology by seeing when I create an edge like this, where does it go? And this is a pretty straightforward thing. It's easy for it to connect up and make a line. But what happens if I want to create some flow to the edges? If I want to create, say, more edges on this side than on this side, that's where it starts to get tricky. And how do we connect those up? So here's an example of an edge that flows. Let's get this here. So our edges actually flow around this. And in fact, I can create as many edges as I want. But the edge also flows along here, and the edge flows along each of these. This is often created, this kind of solution to our topology is often created by extruding something. So I would take any faces that I wanted to extrude, and I would say, let's do selection by 3, holding control down to do this. And I would say I want more edges down here than I want up there. Well, I can do that by doing an inset, and then I would delete maybe these faces, and now I just pull these ones back. And now I have exactly what I'm looking for, a loop that runs up and around and lines that come up and down. This is similar to how we do our elbows and our ankles because we want our loops to be able to go out and around something. It helps us redirect that shape. Here's an example of if I want something that I can take extra edges running down and I don't, like I just want to run them along the side. So I create a little diamond in the center, and of course here we can see it subdivides this way and it turns this way, but it still cuts through that way. This shape I get by taking my point. I want to redirect things. I'm going to take this whole edge and I'm going to hit Control B, and I'm going to draw out this shape. So I start from here, I pull this down, I'm going to turn this into a quad, and now I say I got 1, 2, 3, 4, 5 sides here, 1, 2, 3, 4, 5 sides here, and I've got 4 here. All I need to do is connect this to this, M and last, and now I've swapped that up to I have 4 sides, I have 4 sides, and I have 4 sides, and I have exactly that shape that I'm looking for. Often it's a question of like, if I find an n-gon somewhere, where can I make a connection to break that? Here's a great example of that problem. Sometimes you run into something like this in your model. So I'm gonna go ahead and just clean this up so you can see. Sometimes you run into something like this where you say, I want an edge that turns a corner like this. Or maybe you want to draw a feature and you just take your knife tool and you're saying, well, I want a line to go here, and then I want it to go around the corner and up like that. And you run into this exact problem. How do you solve it? Well, you solve it by taking your knife tool and going from here to here and taking this one edge and turning it into 2 edges. The minute you do that, you can see we've actually created 3 quads out of this one n-gon and this one triangle. Doing the same thing over here, here to here. Often it's just a case of chasing down, and I'll show you in the practical sense when we're actually doing the retopology for a head, how sometimes you're just finding and forcing and chasing down these quads to try to keep the flow looking well. We can see here, my edge flows that way, my edge will fly that way, but it'll also flow this way. Again, see in this example. So why are quads important for deformation? Well, let's compare these two. I'm going to take both of these. Let's pull them to sculpt mode. And I want to take this one. And we can see if I'm in G, and I'm going to try to simulate the idea of changing topology. Look what happens when I try to grab it. It wants to maintain this point. However, if I take this one here, it can soften. And this point, I know I can overextend this a little bit, but we can see it turns into a circle much better. And it's much easier to control, as opposed to this one here, which will always want to turn into a point. So bring it further down, you can see it's that same thing I'm talking about. Without having these corners like this, it's much easier to deform this, like I might say, deform a mouth to show it grinning or changing shape or talking or moving in some different way. Let's actually turn my topology masking on, and then you can see it a little bit better. But this is something that can change shape, and it can still get loops that add definition around it. Again, when in doubt, can I draw an edge loop all the way through whatever I want to deform? So my mouth needs a whole edge loop. Another thing to think about when we're building this is I've turned on a subdivision surface, but we kind of think about this in powers of 2, because every time we're going to subdivide something using our subdivision modifier, we turn a 4-sided thing into extra sides. So let me take this and show it. And we can see every time we divide it, we turn a 1-sided object. If I set it to simple, it becomes even more obvious. Simple does it without the smoothing. We turn one face into 4 faces every time I go up in number. And that's what creates this nice smooth definition between it. This is what subdividing is, and it helps us to control the shape, and it lets us say at a much, much lower level, when I come into the computer here, make big changes to the overall shape, and then it will subdivide that for me and create the cleanest interpretation it can of that shape. Let's come further down over on this side, and I want to show you now in 3 dimensions why this kind of shape doesn't work as well. So if I take this and I subdivide it, let's shade it smooth, and we'll shade you smooth too. And let's turn off wireframe for a second. It looks okay, but if you get close, you can see that there's that weird pinching. That's that high variance vert I was talking about. Now back here, it looks okay, and you might be saying to yourself, well, yeah, but maybe you don't really need to be building anything off of it. Well, let's say I want to build like a bunny head, and I need some ears coming off the side. Well, it's actually pretty challenging to do that because this doesn't have good geometry for it. Let's say stretch it up and pull it back. Because they're uneven, you can see it's forcing me to kind of get this corner in, and I'd have to fix that and push it out. However, if I'm doing this shape right here, let's apply level 2, maybe a 3 subdivision. Let's do that. I'll go ahead and apply it. On something like this, however, with all quad geometry, much, much easier to control and create a much better shape that can give me my sort of bunny shaped head. And because everything's in quads, it's really easy to do things like do an inset and an extrude to create a shape that I might want. Something that's much, much harder to do over here because everything's in nice and clean quads. So it makes it easier to overall model shapes. It can also help you prototype out shapes if you want something like this sort of soft domed, almost like bullet, or like kind of reminds me of a ghost. Well, by adding extra edges to the bottom, we can control this, and you can see if this is in subdivision smooth mode, if I add another edge here, the closer I bring it to the top, the more control I have over that surface. So I brought an edge in there and it created this shape. I did the same thing here. This, however close the distance is, we call these control edges, and they're often used with a subdivision surface to get nice round or smooth shapes. Over here, we have a cube, and it looks like a nice, smooth, rounded cube, but it's just made up of this exact same pattern just applied. Because if I did this and I just kept taking edges and adding one to each side, eventually I would get that kind of a cube square. The kind of golden rule for control edges is we want 3 edges anytime we want a sharp corner or edge. This is used in a lot of hard surface modeling, especially things like vehicle modeling. This is a technique used very, very commonly. Now, the same thing over here, we have 2 basic shapes. Let's turn on my wireframe again, and they both basically could be making a window. But the question is, which one of these is going to give me the subdivisions in the direction and the angle I want, if I want more definition for it? And which one, if I try to do the exact same thing, is going to be a lot harder to get the right number of edges and definition around it if I want them. Here, this one, pretty easy to just add in an extra division or 2 and use it, let's see, to create something like a picture frame. Because I have the edges flowing around the feature that I'm most interested in. Whereas this one, I could create the exact same shape, but it's going to be a whole lot more work. I can in fact hold control, which takes me to the next closest edge, maybe do a bevel on this, and then extrude it. Basically the same thing, but I'm forced to do something much more complex. And most of the time when you're coming through this, what you'll actually do is see this and say, well, actually, turn on my weld mode and on my target wire and turn this on. It's just way easier for me to snap things in, reduce the number of faces that we need, and make our model a little simpler and flow a little bit better just by merging some things together. So turning that corner into exactly what we have there. This is those high variance verts that we talked about, and they're hard to work with. See what happens when I try to hit Control R along here? Works great. Control R here works great. Control R here works great. Let's do it along here. Nothing, nada. Because the edges have no idea where to go. This is a real problem if I look at it in our face orientation mode, because this is backwards, this is forwards. It doesn't know on this individual vert which way this vert is actually supposed to go, and it can create really messy geometry for us. This one, on the other hand, I can lay verts in here all day long because I have enough space and it understands that there's a straightness. There's only one side to each face. So we want to avoid this kind of thing and instead do this. This is that non-planar face, because the problem here is if I take this face exactly it is and I duplicate it, what if is it this or is it this? Depending on how I slice it, you see how completely different it makes that shape. Oh, I hit, did I hit F or did I hit J? There we go, J. And we can see it's the same shape duplicated exactly, but they become completely different. And the computer is gonna automatically triangulate it. So if we don't control it, that can be really bad. Instead, a tool that you can use with something like this, if I delete this, if I remove this edge, let's just get a step back a little bit before I created that little guy. Something we can do is take this face and we can hit Control F, and we're looking for, oh, it might not be under this menu, but we're looking for Make Planar. So it's under Mesh Cleanup. There's a couple of these tools, and one of these cleanup things is Make Planar Faces. And so it will flatten that face out for me and make sure that it stays planar to itself. So when it does triangulate, it does so predictably. Here's some of those high variance points that I was talking about. All three of these have a subdivision surface modifier on them. And we can see this one just has a big n-gon. And it has all sorts of ugly, awkward looking collapsing in it because it doesn't have any control. This one, by comparison, has a single control point in the center, and it's a little bit better off, but we still get that almost balloon-like surface. Now this one is nice and clean, and what this one has is some control edges, but it also has a technique I really like to use when I'm capping. Some what we call taking an empty cylinder. I'm actually going to delete this so you can see what I'm talking about, because I can take maybe, let's say, to get rid of these faces. I'll get rid of this in here, faces. And I can use the grid fill on this. And it's okay, but you see how it's got corners. It sort of points here with these corners pretty awkwardly. And that's because we need to do something like an inset. So what I like to do instead is extrude, scale, then I can do a grid fill. And just having that extra space of one row here of quads helps it understand that it's supposed to go and redirect there, and we get rid of a lot of that pinching. And if we really want to cut any of that pinching, we need another control edge, maybe right about here. Let's turn that off. We get another control edge here, and then we can see we almost completely eliminate even any sense of pinching in any of these corners, because we're telling the computer how we want this thing to flow. The more distance, as I said before, between these, the tighter the edge. So if I want a really soft edge or a really sharp edge, it's all in how wide is this. So if I want to make this a really sharp edge, I'm going to push this out to the very edges, and I'm going to make this one a lot higher. And we can see because they're a lot tighter together, it creates a much tighter edge profile. Now this here looks like a pretty decent model, but a good test is what happens if I subdivide it. Well, that doesn't look like what I predicted, and that's because there's just one single vert in the middle of it. This one single vert can throw off a lot, and often you'll look at your model and you'll say it looks square, but if you hit one, there's an extra vert there. And we can see when I try to create extra edge loops, it's really making it a pain for me because it won't create any extra loops, edge loops anywhere, any surface, because this is actually 1, 2, 3, 4, 5, 6 sides. 1, 2, 3, 4, 5, 6, instead of the 4 that it's expecting. If, however, I connect these back up, well, the subdividing works just fine again. Or, did I take a couple steps back before I did all those cuts? I can always just take this vert and either Control X to delete it, or I can merge it to last to get there, and then all my subdivision tools work just fine. This right here is that example, something to always check out for. If you come up to your view mode and we look up here into face orientation, we can see that red is backwards and blue is forwards. This has 2 different orients, and I can turn on in this face display my face orientations and see that it thinks one face is one way and one face is another, which if I try to do something like an extrude along, try and extrude along normals, we can see it creates a very strange pattern because it's trying to push it along its own unique normals. And it's struggling because it doesn't understand the direction it's supposed to be. However, if I select both of them and hit Shift-N, it'll conform them in the same direction. And if I decide I want them up, I can always hit Alt-N and hit Flip. And I can do that with any individual face to flip it in any direction I want. And now if I do that extrude faces along normals, it works just fine. So, one more thing I want to show here is how do we set up then for actually getting retopology, and then we'll do our video on creating our retopology. So I'm going to take a default monkey here because it's a great demo project, and I'm going to kind of isolate and hide everything else. Let's apply some nice smoothing to this monkey. So it's going to be nice and smooth. Let's turn off face orientation, and I'm going to apply this modifier. Now this model came with great geometry already. Let's turn off my these little first. So this actually already came with nice quad geometry. It flows really well, but we're going to pretend we don't have that. And the way I'm going to do that is come into sculpting, take a look at my monkey here. Let's turn off wireframe, and we're going to do Shift R because we're going to retopologize it. Maybe go a little higher resolution than that. Okay, so about 46,000. Still not a bad model. Let's shade it smooth, and we can see it looks like a decent model, but the flow doesn't go very well. It doesn't distinguish. It makes a lot of straight lines. It doesn't have loops around key areas, and that's something we want. So how do we actually redo this? A couple things we're going to want to do. For one, we don't want to be able to accidentally select this model because this is just our reference, and I'll call this something like Suzanne_high. So it could be high poly, something like that. So when I look at it, I know that's what it is. I'm also going to turn on this filter, the one with this little arrow here, which means is it or is it not selectable? So if I turn it off, it'll still be there, but I can't accidentally click it. This is important because I don't want to click it because I've got a topology I want to do. Then I'm going to create a plane. I'm going to move it out of the way a little bit. Actually, I'm going to leave it right here because I want its pivot to be basically in a center. You'll see why. Now I want to be able to distinguish between these 2 points by themselves. So up in the display tab under this lighting, I'm going to change color from material to random. This means it's going to assign every new object that I make a completely random color. This is great because it just helps me distinguish between when I'm looking at one and looking at another. This is going to be the basis of my retopology. And I want it to snap and let me snap this new square, this new quad, to anywhere on my surface. So we're going to start by taking this object, and we're going to shrink it down with S, and we're going to move it up with G. And we're going to try to line it up a little bit, maybe with the surface of this model. So rotating it, and pushing it so it sort of more or less intersects where it's going. Now, fortunately, it's really easy for us to snap something to a surface. We just have to come up to this tab, turn on face snapping, make sure project to self is on, and project individual elements is also on. Backface culling is also a good idea to turn on, I think. But these are all on, so now if I turn this little sort of anchor on, and I set 1 and make sure I'm on the tweak tool, I can just grab these points and it sets it down right on top of my model. So we can see it's lined up. Now the problem, of course, is I can't see it. Well, we can fix that too. Come over in here to the right into object properties, and we want to do its display to set the tag to in front, meaning it's always going to be seen forward. The problem with this is if we look on the back, it's kind of going to get in our way. But we can go to here and turn off what's called backface culling, meaning it will ignore any back faces. So we won't see it from behind, but we'll still see the outline. This is what we want, because you're going to be, as you're modeling, going to be working on both sides of something, and it'll get confusing if you don't have this culling turned on. Now, this is pretty cool because with this on, I can extrude, and it'll automatically, as I extrude, try to fit it to the shape. So it makes it easy to grab and extrude, and we can see it's making all of these edges and it's following. This is why we sculpt first and then do topology. It's actually really hard to model ahead with good topology. It's easier to sculpt and just get the shape right because you have enough to think about in getting a likeness right. Then when we've got that figured out, the shape, we come back in and we give it good edge flow and good topology like I'm doing here. But there's even more tricks that are going to make this a lot faster for you. So another one of the things that I want to do on this is, let's see, using something called a shrink wrap modifier. Because if I take this object and I say maybe divide it along here and here, well, these edges are still flat. They don't over conform to what I'm doing. However, if I come into my modifiers and I add this guy here called shrink wrap, and I say what object do I want to shrink wrap to, I'm going to select my target. It sometimes takes a bit of a second. Oh, I can't select my target because it's unselectable, but I can select it from the menu up here. So just go up to that, Suzanne. And you can see now it's actually softened it. There's a couple settings we want to change though. Instead of nearest surface point, it's better to use project and set project to positive and negative, meaning it's going to be able to project itself from either direction. So it's always going to try its best to conform to the shape. So we can see with this off and with it on. And sometimes as I'm making my way through this model, I want to make these edits, but I want them to sort of be baked into the model. So I'll take my shrink wrap and I'll hit Shift D to duplicate it, and I'll take the duplicate and hit Control A to apply it. And so I still have my shrink wrap on with all the settings I want, but it's sort of baked in that shrink wrap to the form. I'm also going to want to do a mirror modifier after that, set to clipping, because I'm going to want to make sure it snaps all those points together, which means that as I take, say, these edges and I extrude them, they'll pull into the center. So now I'm going to create whole edges of things. And as I work my way down, oh, I've got those edges selected too. I don't want all those. I can extrude and extrude, make some adjustments to the points. Sometimes too, it's easier to select edges, and I can do edges and these verts at the same time by holding Shift and clicking on both of these, or I can hold Shift and press 2. But by highlighting both of these at once, I can select either edges or verts, and it works great to be able to nudge and make edits to verts, and then select whole edges and work my way around. So keep going, just extruding as I go, extruding as I go, extruding as I go, and then coming it back into the center, and just making some edits and little adjustments to things. So now it's like giving me a whole loop all the way around my head, and it's all in clean, beautiful, nice quads. It's really good stuff. But wait, as I say, there's definitely more. Let's say that I've got a row, because something you'll do is make your way up around the back. And then I want to start filling in some of these edges. Well, how do I do this? I can't just extrude that out. That's a mess. I could take this and extrude it, and then one, and then merge that together. That's kind of a pain though. So here's what I like to do. I like to instead turn on a plugin that we should have on that's called F2 in our add-ons. So under add-ons, type in F2. It's not on by default, but it's really important, and it does some pretty simple stuff. What it does is with F2 on, I can grab this corner right here and hit F, and it automatically knows that I want to make it into a quad. This is really handy, especially if I want to like change the direction of something, like so. And then when I go from here to here, I can select this edge and hit F, and it will fill those in. So again, it really starts to speed up your whole workflow and process. Sometimes when I'm doing my shrink wrap stuff tier 2, I like to add a subdivision surface modifier on after it, just so I can see things smoothed out. and I click this little button, which means that it doesn't show up in edit mode. So as I'm working, I can do this, and then I can pop out and see the overall look of how it looks smoothed out with more divisions. This lets me start really low and really simple, but then preview the overall position, so I have the fewest number of verts to move as I possibly can. I think just like one or two more things with this though. As you can see, the subdivision sometimes has the problem if it moves inside the mesh. So sometimes I like to duplicate the shrink wrap and move it after the subdivision. So it just kind of helps things snap together. And that shrink wrap I similarly turn off in edit mode so it doesn't slow my computer down. Just as like a little tip, keeps things nice and lined up. Some people like to work with solidifies or other things, but this is also a great way of making clothing. We'll use this a lot next week. And it's a good way of creating some basic topology for things. Let me think if I want one more thing in here. So one last thing that I want to show is sometimes I say I want to like really do this much quicker, and I have a couple edges. So here to here, let's hit F to connect these together. Oh, I just want these edges, this. So from here to here, hit F, and I got 1, 2, 3, 1, 2, 3, running along here. And I've got this opening now. Let's go into Object, Shift D, Control A to bake that in. I have an even number, and so if I want to 1, 2, 3, 1, 2, 3, fill this all in, I could do it all by hand, but of course, the grid fill is really great for this kind of thing too. And it just makes it easy, especially if I've got even number of sides on things. Of course, there's so many other things we can do about redirecting shapes, and we're going to go through that in the practical exercise, but this is basically how we set up our retopology. So we can take complicated shapes and turn it into something that still looks like the thing we want, still has the shape we want, but much lower resolution and much simpler geometry that's going to be workable for unwrapping and stuff like that. So I don't know about you, I would not want to have to unwrap this Suzanne head. All right, the next one, I'll take our actual head and take you through step by step some of the key points on where we need to put in loops, how we unwrap it, and then you're going to be ready to go.